Good morning, good afternoon, or good evening, depending upon where you live around the world. We come back to this series of Sketchup exercises and explorations of the geodesic dome. And as I've mentioned in a previous video, it's more to do with my development and discovery of how you go about drawing them within SketchUp. As part of that exploration, I will scour the internet, find a representation of the dome that I think is where I want to go or with this exercise, and then I create the dome via a process that allows me to examine the end result and make some conclusions or suggestions to myself to how it may have been drawn. Because as we see in these two photos, taken from I don't know where I got them from, but they look similar in the top part of the dome, but the bottom is quite different. Now, it could be that the person just wanted more headroom and they wanted longer legs on the dome than it is on this one. That's plausible, but is it actually a good idea to have an approach to drawing the dome in an ad hoc way where there's nothing actually behind it, no geometry or maths behind it? And I would suggest no, it's not a good way of doing it, because every time you wanted to do an alternate dome, or a different person wants to try it, they're going to be left wanting because there's no actual structure behind the approach or formal structure. Now, these two quite similar domes or pictures of domes have actually turned to be quite cathartic in a way, or revealing, and I'm going to go through how I draw each of them as an exercise and to extend the range of the videos, because as I'm also mentioned, just because I want a certain type of dome or approach to drawing doesn't mean to say it's the correct version. And even, to be honest, the outcome of what I've found may not be the correct drawing method. It may be a bit of a fudge to get to where I want, but it works. And believe it or not, it's actually quite easy. Now, what we start off with, we take these pictures, and if we can zoom in a bit, and we can see that it's 8 meters across, very blurry 8 meters. So I used to make the drawings solely based on the pictures, but then I started thinking, well, why not make them as close as possible the dimensions as showing on the photo. Moreover, because I was doing it differently for each photo, I decided that it would be good to have the different photos of a similar or same dimension on the points that I can determine, like the base, for instance. So this is not to scale, because neither of them are of the same size. That's a starting point there. This may well be not an 8 meter, a picture of an 8 meter spanning dome. But for my purposes, we've got a set measurement here. We're going to call it 8 meters and scale it accordingly. Now, if I move these, well, I'll move this single photo, I'll move them both back. Move them back into the plane that we normally start with. And we can see the scale of it. Jeff here, he's, let's just say 6 foot. Well, not to scale, is it? So if I'm going, what I start, rather than waffling on as I often do, I rotate it up so it's in its correct orientation, and I can scale this one of two ways. The easiest way is just to grab the corner, hit what for my keyboard is S, and then drag it out until such time as the measurement that I will draw on here in a moment gets to be 8 meters, or as close as the scaling approach like that can achieve. Or I can use the tape measure, draw on it, and then scale the whole model to that particular size, which is one of the methods we'll use. What it does do when you've got two photos, if you use the second method, it will scale this as well, and if this is not the same size, then you've got it will be just proportionately bigger and still not to scale as we would want. So this first method, all I use is a guide. I bring it as close as I can to the center of the fuzziness, which is the dimension line. I'll draw out another one. This is obvious to everyone that does any drawing in SketchUp, so I apologize for those people that are yawning already. But going through the process isn't a bad thing, I believe. So we've got I'll get rid of the guides now. So I've got a dimension within the picture. I can grab the picture and the dimension, hit S on the keyboard, and I can draw it out until I can get close to 8 meters. Now it's snapping between the points, and it becomes quite difficult sometimes to get it to your preferred dimension. So it's snapping in a 100th point there, so it's a little bit over. I'm going to do the same in this instance with this photo. Rotate it so we've got a starting point that they have at least a close relationship as far as size goes, as I'm bumbling around here. So I put the guide on there. Again, this is one of the points. This, because it's a 3D representation and you've got thickness of the strut members, it sometimes becomes a wee bit of a guess just where you're going to put it, because as we can see there, we can see it's very hard. Actually, I'll go back to the cursor. You've got the width of the timber there and the depth of the timber there. So where do you draw the line? Well, I suggest you get as close to the top edge. In fact, I'll just say it's a guess. So you make your best guess. I'm going to suggest there wouldn't be unreasonable. I'll make another one over this side. Sometimes the photos are better than others. This is not a particularly good one. Draw a guide up, put a measurement in between. Get rid of the guides. Scale until I can approach the 8 meter. That's pretty close for a starting point. You can see quite easily, and especially if I lift this up so it's close to the other dome, they are they're visually quite different. But I would suggest it's all to do with this bottom leg. If I move from that point there down to there, you can see that while these are the same height, roughly, the height of the dome itself is quite different still. So you would have to ask, what approach was used in the dome's creation or the method of production compared to this one? And that's a jolly good question to have asked. Okay, so we've got our two domes scaled to roughly the dimension that was indicated on this picture. So what do we do next? Often you'll get photos, pictures, plan drawings which actually include the side elevation, front elevation, side elevation, and a plan view. Now, I thought it was always better to have a plan view because you can generate the intersections a lot easier. And that's true, but quite often you only get one particular picture. Each of them have a different approach to how you can generate your 3D SketchUp drawing. This method I'll quickly go through because it's taking too long, because as I normally keep on saying, referring, I like keeping the videos to around about 10 minutes long so you don't have to listen to my voice for a prolonged period of time. However, this one we just want to get to the point where we can replicate this and this one in the same method, and then I'll give you an alternative method perhaps, or maybe not. So I start out by putting in lots of guidelines, and I found having a method, systematic method, and a particular approach can help alleviate some of the problems that are generated, because you don't know that this is, or generally they're not, that you don't know that this is perfectly aligned such that the photo will generate points that are which should be at the same level, in the same level, and just your inaccuracy of drawing can be a bit of a problem. Again, more waffle, and I'll stop there. So we put a horizontal line there through the hubs, so we ensure that at least when we draw in a line that they're going to be in the same plane, same height. And I suggest you only work on one half of the photo, and then you can rotate what you draw here over onto this side. So I'll pause the video just now, and I'll draw the lines. I'll do a couple, and same here. I'll put a guideline up at that point, a guide up at this level, and a guide up here at the apex. And all we do then is draw the lines between points of intersection or suggested points by our eye that represent the lines of the dome. So I'll just draw one more and then I'll pause and when I come back, once I fire up the recording again, I'll have these lines drawn. Okay, be back soon. Okay, that didn't take long at all. And as you can see, as I was drawing the lines, some of the intersections would create the faces because they're closing the geometry to allow faces to be drawn. So I just go through, delete those, and then you've got the lines from one half of the photo on one side. I've got the center line. You don't want to replicate these, so I can now take those lines, select them all. I can then rotate them through the horizontal, rotate them 180 degrees, which I type in. I can hide the grids, and I can hide the photo, and now we've got the outline of the geodesic structure from a plan view. I can group that together. Now rotate it 90 degrees through the horizontal. Save both of them. because we don't want this interfering with our model later on. And now we've got a structure such that we can draw lines and form a dome. I can do the same on this side, draw through the grids, intersection points that are close to what I want, and then generate the dome. Now, I won't go through both of them because the approach is the same, so it would be redundant. So for the moment, I'll get rid of this, which I'm calling type 2. I'll get rid of that, and I'm just going to delete that. Okay. I might stop here because it's gone to about 15 minutes now. So we can come back to this as our starting point for how we create the dome. And this is going to be able to be done on most photos. However, a photo will have the inbuilt perspective which distorts the end result, of which I've done, and it doesn't give you any clarity on how the approach to the creation of the original structure was achieved. So it's better if whatever photo you get is of a rendered or a generated from like a drawing program, like those two photos were. Okay, as I said, I'll stop now. I'll go away and come back very soon. Okay, see you later.